Okay, so looking at how this relates to climate change, before I start, I'll give you the secret word of the day. Secret word will be bottle cap. So, um, for climate change, what scientists will do is they'll have a model for the data that we have already. So, the historical data that we have from as long back as we really can. Well, I guess we want to go back until when humans started affecting the climate. We don't really want to look back in time when humans weren't affecting the climate because humans are a new factor. So, we'll look back maybe 5,000 years to now. We'll model that data. We'll get kind of a mathematical equation that fits the data, and then we will use that to predict the future. But on top of that, we'll look at these factors that are going to affect climate change that we talked about above. And using those factors, we'll say, okay, we're going to have more CO2. Because humans are getting more and more populated, more things are happening. So this curve is going to go more a bit higher or a bit more. So we're going to change some of the factors or some of the values in the equation. Or, oh, we're going to get new technology that's going to really help us pull some CO2 out of the atmosphere. So this curve is going to go down. So we use these factors as well as this equation. So we add them together. So with any model, because there's so many factors, we're going to get a best case, a worst case, and a predicted case. So if we look at the graph below, this is the sea level change relative to 1990. So we have 1990 being 0 on this, and we're going to look at how much we predict the sea levels to rise up to the year 2300. So we have a worst case scenario is going to be the top of this gray shaded region. So this is going to be, if everything goes wrong, this is what's going to happen. Then you got your best case scenario is going to be the bottom of this gray shaded line. And that's going to be, if everything goes right, this is what happens. And then what the scientists predict what will happen, what we think it will actually look like, is this going to be this dotted orange line. So everything in the shaded region, it says, okay, it could be anywhere in this region. So if we look at 2300, they're saying that the sea levels could rise by 2.5 meters to 5 meters. So converting from centimeters. So that's quite a large range, almost could like double the value. So that's because we're quite a bit further in the future. So the further we go into the future, the harder it is to predict, the more error we have. So the error in this would be 1.25 meters. If you go, the dotted line is going to be like 3.75, and you go 1.25 above that to get 5, and 1.25 below it to get 2.5. So you have an error on your values. So if we look at the data here, now the best case scenario, so the bottom of the gray shaded region, other models have shown better best case scenarios, so the sea levels rise less, but things need to happen quickly for that to happen. So let's look at this predicted case of the dotted line. So if we look from 1990, currently our sea level has risen about 10 centimeters from then. So in 2020, we're about 10 centimeters above what it was in 1990. That means the model predicts that we're going to be about 3.5 meters above where we are today by 2300. That means that Parkland's for sure underwater, and then the building shouldn't be around by then. That would be a very old building. But like the area that Parkland is on, that would be underwater, and most of like Sydney by the shore would also be underwater. So that's quite a bit. And if we get to the worst case, we're up 5 meters. That'd be almost 1 billion people worldwide without homes. Now they have to move. And it wouldn't just be like all of a sudden sea levels just jump up. But that's a lot of people to try to move into new areas over time. So if we want to get to these best case scenarios, we have to make immediate change. And that's something we'll talk about a bit more. So I'm going to just talk kind of through the graph on the left here, and then I'll get to some of the points I want to make after. So we have 4 graphs that show different values for different predicted models. So this research group went through and made 5 predictions on how climate change will go in the future based on different models. So if we look at the dark blue or the dark blue dotted line, this is the best case scenario. This means that we have made immediate changes and we're reaching all the goals set out. So the Paris Agreement, that's where all the countries came to get, or majority of the most powerful countries in the world came together and made an agreement on how they are going to react to climate change. And the agreement was to be carbon neutral by, I think, 2050 was the agreement. So the dotted blue line would be matching that agreement. And then we get to the dark red, that's our worst case scenario. That means we're not making any changes until we absolutely have to make changes because the human population cannot survive that year without making changes. So we're like leaving it to the absolute last minute. Okay, so with global warming, or with the global warming power, so that's going to be your first graph here. So global warming power is watts per meter squared. So that means per area. So if you look at my depth on the screen, that would be about a meter. So just past my shoulders up, about a meter squared, and it's figuring out how much energy hits that spot on Earth. And we talked last time, or 2 days ago, about how when light hits Earth, it reflects out and it becomes infrared light, and that means it's heat. And it hits these greenhouse gases and it gets redirected. And some of that's going to get redirected towards Earth. So when it gets redirected towards Earth, it lands on one spot, and that's energy line on the spot. So we can measure how much energy lands on that spot. And currently, right now, we are about 2.7. So our best case scenario sees that if we look at that dotted blue line, we don't go above 3. We maybe get to 3 and then we start dropping. And that's great. It means we're not warming up each spot of land. And I should say that this is like an average worldwide. So like in the Arctic, we're not getting as much energy per square meter hitting Earth, and like at the equator, we're getting a lot more. So this is just like a world average. So best case scenario sees that we revert this curve and we're going to actually flatten it, and it's going to get negative. So we're going to decrease the amount of energy hitting each square meter, which is ideal. It means Earth is going to start to cool down a little bit. If we look at the worst case, that dark red line, we see that we make no change to fit this curve, and we're just going to keep going and growing more and more and more to where we almost triple the amount of power hitting each square meter. And this power is directly related to heat. So if you think I think a couple years ago, the roads were so hot in India that people's sandals were melting to the roads. And that's because they're getting so much heat from the sun and greenhouse gases. So if this global warming power increases more and more and more, the roads are going to heat up even more. And we're going to have to find new ways to cool the roads, or new technology for shoes that don't melt in the roads. I think that's all I want to touch on that one. Okay, so these next two graphs kind of go hand in hand. So the first one is total carbon dioxide emissions, or CO2 emissions, in billions of tons per year. So right now we're about 44 billion tons a year. So the dotted line is 2010, and the next point here, this is going to be 2020. So right now we're about 44. So we're kind of aligned with this orange line, or maybe the red line right now. So we have yet to kind of drop the line to where we're at, like the blue, the best case. We're not there. We're above the best case scenario right now. So we're closer to the worst case scenario than the best case scenario. So this is how much CO2 is emitted into the atmosphere each year. Now, 2050 is going to be right between these two dots here. And that corresponds with when the Paris Agreement decided or planned to have the world be carbon neutral, which means we are absorbing the same amount of CO2 that we're emitting. So that's why we get to 0. It means we're emitting no new CO2 each year. So that's the best, that's what we planned for. But all the data is saying that we're nowhere near being able to reach that goal, that we're not going to be able to reach it, especially if things continue the way they are. So we need to have drastic changes immediately to reach this agreement, this goal. And when we see the worst case scenarios, by 2050, we're we've doubled the amount of CO2 we're putting in the atmosphere, and we are not fixing things until we absolutely have to. If we go below zero, that means we're pulling more CO2 out of the atmosphere than we're putting in. And this would really help us control the climate. So if humans have the technology to be able to put more CO2 in the atmosphere if we need, which we're definitely good at, and take out CO2 if we need, we could really control the temperature of Earth. So we could stop Earth from getting too cold, and we could stop Earth from getting too warm. So that would be ideal for humans anyways. I don't know how that would work for animals, but I think climate control, like you see these movies about how we control the climate, just by being able to use CO2, we can definitely control the climate. So that's the first graph. The second graph just shows the concentration in parts per million. So again, parts per million is if you take 1 million particles in the atmosphere, how many of those will be CO2? So we can see that if we look at the best case scenario, it doesn't go to zero because we can't have like negative CO2 in the atmosphere. We won't have zero. We'll still always have some CO2 in the atmosphere. But the goal is to stop this curve from increasing. So if we have negative, if we're pulling CO2 out of the atmosphere, then we're actually going to reduce that concentration. So that's how the curve starts to move down, is because we're pulling CO2 out of the atmosphere. So the 3 blue lines are kind of what we hope happens. If we're anywhere near the red or orange lines, or even the dark red lines, things are not going to go well for us. So we need to get to these blue lines. And the last graph we'll look at talks about temperature increase. So this is kind of pulling all the data we had above in the 3 graphs, and we're going to figure out, okay, how do these relate to temperature? So scientists have done the calculations and to relate CO2 and the global warming power unit to temperature increase. And we can see right now we're 2020, and we're about a line 1.2, 1.3 degrees Celsius above the average temperature. And this average temperature here is calculated from 1950. So in 1950, this was the 0 point. So we talked about maybe 5 lessons ago now. We said that with polar ice caps, if the average temperature is above 17.5 degrees Celsius on Earth, there'll be no polar ice caps. So if we get to the point where temperatures increase by 4 degrees Celsius, that'll push us to 18 degrees Celsius yearly average, which means we'll have no polar ice caps. So that, not that we want to like get close to that, but that 4 degrees Celsius or that 3.5 degrees Celsius increase is really the point where, okay, things like Earth is, all of Earth is a tropical climate. Around the equator might be inhabitable, would be so hot. That's the worry, that we get to the point where we can't fix this. If we look at the dotted blue line and the blue lines, these are the ones where we've controlled the CO2 output almost immediately, and we really started to make changes on that. And even with these, we don't see the temperature stop increasing until about 2050, 2060, 2040, depends on the scenario. Or even with the light blue, it's going to increase up to 2100, where even though we're making steps right away, we're not doing them fast enough, and temperature's still increasing. We're going to get to 2.5 degrees Celsius more than it is today. And that's the scary thing. Even if we take action, the temperature is going to keep increasing. And as the temperature increases, we talked about, the storms increase, the droughts increase, the harm on animals and ourselves increases. So really, this dotted blue line would be ideal, where we start in 2020 or 2040 with the temperature no longer increasing, you're going to start decreasing. Okay, so that's everything for today. I hope you have a great day, and I'll see you next time.